Oh, whatever. Hi everyone, welcome to the session on ML using Python. This is module 2, part 2, what we call as session 3. And Jaymeet Vasava has been doing excellent job and we have a lot of response. Although some of them view the records on the YouTube. So you are welcome to watch the records on the YouTube if you miss anything. Today's anyway is a continuation of the module 1 and 2, anything that is required on exercise front, Jupyter notebook, etc. That will be handled by our instructor, Jaymeet Vasava. Welcome, and with that I will hand over to Jaymeet. Go ahead, Jaymeet. You can continue with the presentation.
So thank you for the introduction. So hi everyone. This is module 2, descriptive analytics, and it's part 2. In the previous module, we discussed about data frames. What is data frame? We explored some of the ways to handle data and made prepared data for our use. Uh, uh, Using the filtering, grouping, ordering, and joining of data sets and such kind of operations. Then in the end, we discussed about handling the data with missing values. In this analytics session, we'll be discussing about data visualization. And we'll be using two libraries, which are Matplotlib and Seaborn. And using those two libraries, we will explore some of the methods. This will be an introductory one for Matplotlib and Seaborn, both of them. And we explore some of the functions that they provide. And also, we'll be keep on exploring as we keep on continuing with the further future sessions. About the different functionality that both of these library provide us. So in this session, we'll be discussing about different plots that these libraries provide and stuff. So as we already talked about what we discussed in the last session, which was about handling missing values. We now will be using visualization, which enhances our understanding of the data set that we have been using. So why data visualization? Because it allows us to visually represent data, making it easier to uncover patterns, trends, and insights. By transforming our data into graphs and charts, we can gain a clearer perspective on the details it has to offer. Now, visualizing data is always easier in order to interpret on a larger part, because it shows us how the data has, what the data is trying to show in a very visual way, and makes it easier for us to interpret the data. So the two libraries, as also mentioned, we'll be using Matplotlib and Seaborn. Matplotlib uses NumPy more and does have the a good support for pandas as well. Matplotlib kind of gives you a more functionality and control for your visual representation, whereas in Seaborn, it gives you more easy interface or simple interface to work with pandas, and also the visualizations that are created, they are more aesthetically pleasing. So first we'll be discussing is a bar plot. So because we have just uh, introducing these two libraries, we'll be using a very simple program in order to discuss these two libraries and uh, show how they operate. So I have taken a list called categories and a list called values, and both of them have their own own value own values or own elements contained within them. Now PLT is simply matplotlib is simply imported as with the alias name PLT. So PLT.bar, it helps us to create bar plot, and when we give the corresponding values to the of corresponding variables, it creates the bar plot. Now PLT.title, it gives us uh, the ability to give a title to the bar plot that we are trying to create, and X label and Y labels are nothing but uh, which values are we trying to show, or which features or which features are we trying to show. So it's just a label for X and Y axis. And plt.show, though it's not necessary, plt.show, it makes sure that uh, it that the graph that we have made, it appears. So first we'll be importing these libraries, though this very example uh, that we are discussing is mainly only for matplotlib. So we can also start discussing from here. So remember we discussed about the categories and its values, and then gave a bar method to create and gave the corresponding values to it. And when we and then give the title, the X label, Y label, and then in the end show to make the plot appear. So this is how it looks like when shows, and it shows that category 1 has a value 10 and stuff. Category means at first index it's A, and then value 10, B 15 and stuff. Now we'll be using both the libraries for our use. So in Seaborn, instead of we are using bar as the method to create the bar plot in matplotlib, in Seaborn it's a bar plot method, and what it takes is X, and it's for X, which values will it take, so we have to assign that. For Y, which values will it take, we have to assign that, and then the data from where we are taking it. So we import the necessary libraries, then we are creating a dictionary called data. uh, we are we are creating data, and then we have the same category and values both, and the same A, B, C, D, E, and their respective values. Now we are creating a data frame out of the data that we have used. Then using SNS or SN, you can use both for an alias for CBON. Then giving the uh, respective arguments their values or the argument that they take. So for X, we are deciding to go with category. For Y, we are going with values, and then the data from where we will be taking the data. So we have created a data frame called it DF. So DF, and then in the end, the title, X label, Y label, and show. So these are the necessary libraries. And matplotlib.inline, this part of the code, this line just makes sure that the visualization that we are trying to create, it appears in the cell, in the very cell as an output and not as a separate window. So you can see this is appearing because we have given this. So we have already discussed about the code. You can see that this is how have we are getting the visualization for the data or for the DF data frame that we have constructed over here. Now, remember that in the previous session, we discussed about uh, players and which are the players which carry a premium price. Premium price is nothing but that is a base price, and which players were sold on a price which was greater than the base price. So we created a data frame for that, which presented the name of the player, the base price that these players possess, and the selling price that these players had. And the difference that was there in the base price and the with the sold price minus base price, we called it a premium. So this was for in a ascending value from lowest to highest. So to get the player's name who has the highest selling price, we got the ascending equals to false, or printed it in descending order. So these are the values that we get in descending order for from high to low. After that, we also wanted to check according to the age group. Now here we are not creating age as a number, but age as a category. So for age category 1, these are the players who are smaller than 25. For age category 2, 25 to 35. And for age category 3, it's age more than 35. So uh, which is the uh, selling price of or the average selling price of each of these group. So you can see that for age category 1, age category 2, and age category 3, these are the average selling price for them. Now we wanted to see how the age category that we just discussed about, and within them which players according to which role are getting uh, their what kind of price they are getting for as a selling price. So in the data frame that is appearing below, you can see that there are age group 1, 2, and 3 all grouped together, and which kind of players most of them possess. So you can see that age category 1 possess all-rounder, batsman and bowler. Then category 2, they also possess a bowler and wicketkeeper. Additionally wicketkeeper, and same goes for age category 3. Now, according to playing rules, which which age category is getting the which kind of selling price, that was what we were trying to see. So this is what we got. And you can see that uh, index 7 and index 10, there is both of them belong to age category 3, and one is all-rounder and one is a wicketkeeper as a playing role. So these two are higher in the setting or in the selling price. Then we also discussed about the comparison of the selling price according to role and according to age, and which one belong to which age group as well. So you can see that the premium that we discussed here, it is basically the sold price minus base price. You can see that the same premium is denoted by change over here, and you can see that how the price changes for according to age, and according to age as well as the playing role that these players possess. So with those contexts, we will be discussing and trying to visualize the selling price of players by the age. So remember that we had three categories, 1, 2, and 3, for different, which denoted different age groups. So in Seaborn, we use a bar plot, as also mentioned before, which makes the bar plot. What it takes, it takes the x values. So here we will be taking the x values as age, which are three categories basically. Then comes the y values, which will be uh, taking the selling prices from where these players, uh, which are the minimum and which are the maximum selling prices. So a selling price basically, and the data it takes. So from where we are taking the data, we are taking the data from sold price by age data frame. So when we plot the graph, this is how the bar plot looks like. So we have for the selling price age group 1, which shows the maximum uh, selling price according to their age group. So you can see the execution over here, age as x value, sold price as y value, and sold price by age as the data frame. And this is the graph that we get. So for average sold price, each category but grouped by a third variable, that is a playing role. So the parameter u takes a third variable as a parameter. Okay, sorry, this was for next. So let's say we want to visualize this whole thing based on the playing role that these players possess. So first we have the age category 1, 2, and 3, and then within them, these age categories will have all the players for all the playing roles that they have. So for each and every uh, playing role within the age category, how the visualization works and how different colors can be used in order to visualize it. So for the same bar plot will be used, but here an additional argument will be used, which is hue equals to playing role. So that playing role will be represented with different colors, and you can see which color corresponds to which playing role. So blue corresponding to all rounder, yellow to batsman, then green to bowler, and red to wicket keeper. So the selling price of is the highest from age group 1 for the batsman. Then comes for all rounder for age group 3, and wicket keeper from age group 3 as well, and so on. So you can see the interpretation for it. The next we'll be discussing are histograms. Before that, let me show you the implementation of. So this is what this statement that I read mistakenly as in context. So this above one, this statement was for this is to create this bar plot. So hue is the additional argument which takes a playing role as an input to show that these playing roles in different colors. So this is the output that we get for it. Next are histograms. So histograms are graphical representation that displays the frequency distribution of a continuous variable. It consists of bars that represent the number of observations within specified intervals or bends, allowing for a visual understanding of the data's distribution or a central tendency and variability. So it's a syntax to use a histogram is of course a PLT matplotlib. So it's a matplotlib's method called hist, and it takes the data frame as an input. So when we use it to plot the selling price of the players that from the data set, these are the values that we get for it.
What are the X and Y
Yeah.
in this?
No, it will directly take a data frame as the parameter.
Okay.
Yeah. So, so because you can see that this is not a good representation, and kind of blends in the different bars, blends in within them. So you can use another argument called edge color, and just give it a value of black so that it's more readable. By default, you can see that there are 10 10 bars that are created in histogram. That's the default value for it. But if you want more number of bars, you can give bins equals to 20 as an additional parameter to the one that we have discussed. And you can see now that there are more number of bins to, in a way. So, so in this bar plot, you can also see that for on x-axis there is a value of 1.75. So at the value of 1.75, there are total 4 players that were sold around that price. So this can be an interpretation. So y-axis are the number of numbers, and y-axis are is the sold price. And this graph fully just shows us that how many players according to price were sold. So 1.75 also feels that it's denoting a premium rather than a normal selling price, because there are 16 total pairs who have been sold at a zero. So it just simply means that they are sold at a base price and with no premium at all. So we discussed about the histograms, and we use a hist method of matplotlib to to visualize the selling price of the players called sold price in our column. This is the visualization that we get, but to make it clear, we add arguments edge color equals to black, and also bins equals to 20, as by default there are total by default it will only create 10 bins and show us the representation. But when we give bins equals to 20, you can see that we are getting more detailed view on which how many players were auctioned or sold, or sorry, sold on which price. Next is a distribution or density plot. Will only say it as a distribution plot, as the Seaborn method, or uh, it says that sys plot and not a den plot or something. So that's the reason we'll only refer it as a distribution plot. So Seaborn has this method of a distribution plot for creating the distribution plot, this plot, which takes a selling price as a or sold price. Now remember that there is also a method called dist plot, dist, but it's a feature that they are no longer going to use it. But right now it is in use as we are recording this. So we'll be using dist plot right now and create the same kind of distribution for it. So, distribution of or the density plot, it depicts the distribution of the data over a continuous interval. So density plot is like a smoothed histogram and visualizes the distribution of data over a continuous interval. So when we for the code that we for the line of code that we used to create this distribution plot, sn.displot method, and we used simply the argument which displays the data. But in if we add a kde uh, equals to true, which is another argument, it will show us a line which kind of shows the flow of the data and how the selling price goes, and it shows us a smooth representation to how the selling price is going through a different price range or price numbers. So KD helps us identify the underlying distribution of the data, revealing features such as peaks, valleys, and overall shape. So that is why this KD feature is used, or this argument is used. So this distribution or density plot, this dist plot or dist plot method represents the univariate distribution of data. That is a data distribution of a variable against a density distribution. The cbound function, or sorry, cbound method called dist plot accepts the data variable as an argument and returns the plot with a density distribution. A distribution or density plot depicts the distribution of data over the continuous interval. Density plot is like smooth histogram and visualized distribution of data over a continuous interval. So for the disk plot that we saw in the slides, this is what we get. And by the way, there is a semicolon over here. If you do not enter this semicolon, the code is still going to run with an object that shows above the graph. So you can see this thing appears if we do not add the semicolon, or we can also remove this by showing plt.show or something. So it will get removed. So you can see that here we do not have a line guiding us through the valleys and stuff, valleys or peaks of the graph. Here, as we entered the argument kd equals to true, we have a line or a curve like structure, a curve which shows us the peaks and lows of the graph. Next is a box plot. So we'll be using the Seaborn's box plot called sn.box plot method. Before going to the visualization of the box plot, let's just introduce the box plot as a concept. So box plot is designed by identifying the following descriptive statistics in the data set that we are going to use. So what does it identify? It identifies the lower quartile, the median, and the upper quartile, the lowest and the highest values, and the interquartile change. Now, what is this lower quartile and upper quartile denoted by Q1 and Q3? So Q1, which is the lower quartile, it signifies, or it represents the value of the data which is 25% or below it. The upper quartile represents the value below 75% of the data lies. And the interquartile change is nothing but the difference which shows the 50% of where the 50% of the data lies. So you can imagine this as a distribution of the data, Q1 signifying 25% or below, Q3 signifying 75% and below, and the difference between them showing the where the 50% of the data lies. So if we want to calculate the lower limit and upper limit, you will see why we want to do that. So this is the formula to it. And if we want to, when we calculate the lower limit and upper limit of these quartiles, we get something called uh, a limit to the lower limit and the upper limit. Now these lower limit and upper limit help us to identify some of the outliers uh, that can be present in the data. So if the value is lower than the lower limit, it we know that there can be a potential outlier at the lower end. If we have a value greater than the upper limit, we know that there is a potential outlier at the upper end. So this is how a box plot looks like. So when we say about uh, the lower quartile and upper quartile, this vertical line of the box plot, you can see this is what they signify the these values. So we'll be using the Seaborn's box plot in order to visualize this, and the selling price again. So we have the uh, lower quartile and the upper quartile denoted by the vertical lines that are represented in the box plot. Then comes the interquartile range, uh, which shows the 50% where the 50% of the data lies. And then anything beyond that, you can see that in the vertical line on the right, there are 4 dots. This means that there are outliers at the upper end of it. So for this representation, you can see that it's in a horizontal manner, as we have given the box plot x equals to IPLDF and stuff. But if we do not give anything, then it will be in a vertical manner by default. So you can see this is Matplotlib's box plot being used, and by default it's in a vertical fashion, and it also shows those 4 dots for the outlier. So now you can see that now you can imagine it in a much more better way of what the low quartile, the upper quartile, and also the interquartile range signifies. So we have total four dots. It does not necessarily mean here that there are only 4 outliers. There can be a situation where certain data points are overlapping over each other, or certain values are overlapping, and hence the dots can overlap as well. So in order to get that, we'll be using something called as item.getYdata method. Now that getYdata method, that is used to get the coordinates of the y-axis for the items in box, and then giving it a value of caps. These capture the lower quartile range and the upper quartile ranges value. So the lower limit and the upper limit, and gives us. So item.getYdata and give it the value of 0, retrieves the first value of each cap in the box plot, which corresponds to the top or bottom end of the box plot whiskers. So whiskers are nothing but you can see that the box is being connected by a single line, and then it shows the quartile range. In this, if we talk about in this very figure or the diagram, the box is being connected by a vertical line, and then in the end the horizontal lines showing the limits. So these vertical lines are called whiskers. So when we give box caps as the value, it grabs the upper and the lower or the top and the bottom end of the box plots whiskers and give us its value. So a bit of about Y data. So Y data is a method of Matplotlib's artist object that returns the Y coordinates of the data points. Now Matplotlib is related to MATLABs. So if you want to, and this is where the artist object is referring to. So if you want to learn about it, I will share a link which showcases about the correlation of artist object, different layer and stuff, which it coordinates with Python and executes certain functions. So the regarding so the caps in the box variable returns the minimum and the maximum values of the distribution. So this is the same code as before. So the minimum value that we have is 20,000 and the maximum is 1,35,000. So the whiskers key in the box variable returns the value of the distribution at 25 and 75 quantiles. How we do that? Instead of caps, we give it whiskers, and it will give us the value of it. By these values, we can calculate the interquartile range, which comes down to 4,75,000. And if we want to calculate the median on it, we get item.y data and 0 for its value, then iterating through for loop for item in box, and then giving the value of medians, we get the value of 4,37,500. So this is the median value of the selling price. So before we move on further, so what the box plot tells us, it tells us about the lower quartile range, the median, and the upper quartile range. Then comes the lowest and the highest values and the interquartile range. So we plotted the graph for plotted the box plot for sold price, and this is the plot that we got. If we want, then this is the plot that we plotted using matplotlib. As you can see, plt.boxplot, and giving it saving it within the instance of a box. So this is what we get. This showing the lower quartile, the upper quartile, and the 50% of the data where it lies. the minimum, the maximum, and the minimum values, and these are the whiskers. And these, what the dots are showing, are the outliers. So this box plot returns details of box plots in variable box. The catch key in the box variable returns the minimum and the maximum values of the distribution. So you can see that minimum is 20 and the maximum is 1350, 13 lakh 50,000 basically. So this is the output that we get for it. Now, if we want to see the values at the lower end and upper end of through the whiskers, these are the values that we get. And from this, we can calculate the interquartile range by simply subtracting 700,000 minus 225,000, 225,000, and we get the difference of 475,000. Next, we discussed about just the way we discussed about the caps and whiskers. The median gives us the median value for this, and 4,37,500 is the median value. So after knowing the upper and the or the minimum and the maximum values of the distribution, and the through the whiskers, knowing about the lower and the upper limit, and also knowing the median, when we plot the graph, we saw that we are getting outliers. We cannot, for this data set, we cannot be sure that there are only 4 outliers, and we'll see why. But they are showing they are showing 4 dots. So let's see. So first we will be checking for the conditions whose through the IPL auction DF that we have been using, and within that the selling price called sold price. So if the sold price is going to be greater than 13 lakh 50, which are the players, and what we want regarding them is the player name, playing role, and sold price. So when we displayed the result, these are the players who have the selling price of more than 13 lakh 50, and for what role they were and what role they are playing. So you can see that we were getting 4 dots for these representations or visualizations that we made for the selling price. These are the players or the outliers we can see that that cross the limit of these values. So even though just for the reference or the context, even though I'm telling the prices in uh, lakhs and stuff, these are for millions. So this is not 20,000 rupees, but rather than dollars. So it's 1.35 million dollars. Next is comparing the distributions. So we can use two different distributions and then compare them by overlapping them. What we mean by that is, let's say we want to see that what is the selling price of players who have no captaincy experience and who have a captaincy experience, and then compare the results and how the visualization is, uh, what the visualization tells us about it. So we'll be using the this plot for Seaborn from Seaborn and giving him and we'll be using the IPL option DF, and what we'll be using captaincy experience, and which will be equating equals to 1, and there and clubbing together the selling price of it, and how we want to represent them with color value equals to Y and the label captaincy experience. For Seaborn's distribution plot for no captaincy experience, will will go through the same column of captaincy experience, but the color of representation will use is red, and the label will be no captaincy experience. Then in the end, the legend, to show the legends, uh, legend is basically the no experience, no captaincy experience and stuff. You can see in the within the graph showcasing which color corresponds to what data, that is legend, and then title, the X label, Y label, and in the end showing the graph. So this is what it looks like. You can see that there can be players who have no captaincy experience but have a high selling price. But you can also see that the sorry no sorry you, sorry, I made a mistake in interpreting. So you can see that in this graph, the captaincy experience, which is denoted by yellow, uh, it is getting a higher selling price, and the captaincy experience is indeed important for the player for having a higher selling price. So regarding this, we are using Seaborn and then his histogram plot in order to overlap these. We are not using this. I'll be showing the disk plot implementation as well. But if you want to overlap uh, a plot, you can use a his plot like this. We are using IPLDF, and within that there is a column called a captaincy experience whose value equals to 1, and we want to see their selling price as well, represented by color yellow and label captaincy experience. Now KD we have already discussed, and we'll be stating KD equals to 2 for both of them, for captaincy experience and no captaincy experience. Below will be the no captaincy experience, where we'll be equating it equals to 0 and show its show the player's selling price and being represented with red color. So this is the plot that we get. And you can see that over here, uh, in the yellow is far above for the selling price that it has because of the captaincy experience. So this shows that the captaincy experience indeed matters when it comes to a player's selling price. Next is comparing distributions using the box plots. Just a second. So in the slides, we discussed about the overlapping of distribution plots using displot. So you can use this. This is the same kind of graph you will get it, but you will also get this message that displot is no longer a feature is and will be removed in CPON CPON version this. So instead of that, you can use a his plot. So that is the reason we used his plot over here instead of this plot. So, but as we are recording right now, this plot is still available, and we are able to use this. So this is the graph using the disk plot. Now, comparing distributions with the help of box plots. So you can see that there are different playing rules this time that we'll be comparing it with, and the selling price. So we have the playing rules on x-axis and selling price on the y-axis. And you can see the box plots that are created, the whiskers and the lower and the upper minimum and maximum values, as well as the lower and the upper limit. So for batsman and wicket keeper, you can see that we are getting outliers. And if you remember that when we talked about the outliers, MS Dhoni was the one, and he has the playing role of wicket keeper. So you can see that that's one guy who is showing up in the wicket keeper playing role in this plot. So few of the observations that we can get from this plot: the median sold price for all-rounders and the batsmen are higher than the bowlers and the wicket keepers, and all-rounders who are paid more than one. Uh, I'll just pronounce it in lakhs. So 1,35,000. So are not considered outliers, and all-rounders have a relatively high variance. There are outliers in batsman and wicketkeeper category. We have already found that MS Dhoni is an outlier in the wicketkeeper category as well. So we chose a playing role on x-axis, sold price on selling price on y-axis, and then comparing this. So you can see that this is the plot that we get, and the observations that we discussed just now. Next, we'll be discussing about a scatter plot. So in a scatter plot, the values of the two variables are plotted again along two axes, and resulting pattern can reveal correlation present between the variables if there is any. So this relation can be linear or it can be non-linear. So scatter plots are used during regression model building to decide on the initial model, that is whether to include a variable in a regression model or not. So let's say we want to use a scatter plot and we want to check a certain kind of assumption. So what is our assumption? The number of sixers a player has hit in past would should influence the selling price of that player. So we are creating this uh, IPL batsman DF for all the players whose playing role is equals to batsman. And then we are using scatter function, oh sorry, scatter method, giving them the values for x and y for sixers and selling price, sixers on x-axis, selling price on y-axis. So you can see that on the far right of the graph, there is a player who has hit a lot of sixes, but his selling price is not much. So we are trying to, so let's create a code, uh, a line that signifies the relation between them. And we will use a rich plot method of Seaborn in order to construct that line and show us the relation between the x and y values. So like the previous one, it will take the column sixers as x and selling price as y value, and from where it will take from IPL DF, batsman DF that we just constructed, and create a ridge plot. So you can see that it shows a positive correlation between the number of sixes and the price, both of them. Regarding the data point that I mentioned about the right hand side of the graph, it is just one observation, but you can see that it still does show that number of sixes does have a positive correlation with the selling price of the player, as the line is moving down to up. So this is the IPL batsman DF that we constructed using the playing roles value being equal to batsman. Now this will not contain a wicket keeper or something. These are only the batsman values, as you can see in this column. So these are only the batsman values. We create a scatter plot, give the sixers from the batsman sixers, and then the selling price from the IPL DF we just created, and plotting the scatter plot. Now, for fully understanding the relationship, we use a rich plot data, and a linear regression model fit, which will show us the line to display the correlation that exists between the sixers and the selling price of the players. So you can see that the line shows this as it's moving upward. It shows that it has a positive correlation. So as the number of sixes increase, the price of the player is can also increase. Is increasing, sorry. Next is a pair plot, which works for two variables. Sorry. Next is a pair plot, which works for multiple variable. As a scatter plot, we discussed with for two variables, which is number of sixes and the selling price. What if we want to create for more variables? So that is what that is when where we will use pair plot. So let's say we want to check the features that affect the selling price of the batsman. So first is the strike rate, average, number of sixes the player has hit, and or the batsman has hit, and the selling price of the player. These are we think that these are the most important features that affect the selling price of the batsman. So we will create a list called influential features, and we'll have all of these features within them. Then we create a pair plot. How do we create it? We give the first argument for the data frame that we are using. We are directly using it through IPL auction DF and not batsman DF. So which is which contains a list of features called influential features, and then the height equals to 2 for the size of the plot. You can see how which kind of changes happen when you move from for the heights value of 1, 2, 3 and stuff. So this is the what how the pair plot looks like. I know it's not much visible, but I just want you to get the picture of how it will look like. So let's go to the notebook in order to get it. So we created an influential features, and then created a pair plot using this code. Now, if I zoom in further, you can see that there is a strike rate of batting, average, sixers, and selling price on the y-axis as well as the x-axis, both of them. So you have to how we can compare is that let's say the average and the strike rate over here. This is how the correlation looks like for them. The same goes for average and sixers, how these values look like. So you can also see that there is a diagonal uh, matrix that is showing up, which are these values. So these are the values which shows the distribution of the variable. These. Now, as we have discussed about the scatter plot, and then we used a pair plot for multiple features to be compared and checked whether which kind of things are correlated and not. We will study about the correlation and the heat map. So correlation is used for measuring the strength and direction of the linear relationship between two continuous random variables x and y. It is a statistical measure that indicates the extent to which two variables change. A positive correlation means the variable increase or decrease together. A negative correlation means if one variable increases, the other decreases. The correlation value lies between -1 to 1, and the sign indicates whether it is positive or negative. The -1 indicates the perfect negative correlation, whereas a +1 indicates perfect positive correlation. So, in order to see the correlation of the values, we can use the correlating the values using CORR, then parentheses, as a core method of data frame on our influential features. So when we use this, we get the correlation in a matrix form. And you can see that there is a diagonal matrix also. Now, let's say we want to generate a heat map in order to nicely visualize the correlation. So we'll use the correlation method and then use the Seaborn's Seaborn's heat map method on the IPL auction DF that we have. So we were using the influential features on correlation and then and not equals to true. So this is the heat map that we get for the correlations of the features within themselves. So you can see that a number of sixes and the average are getting the value of 0.7. So you can say that they are highly correlated. Whereas the value for average and selling price is only 0.4. The value for strike rate and sixes are 0.43. So you can say that these values are don't have much of correlation between them. So as you remember, we created this. We used a correlation on the influential features of the IPL auction DF that we have been using. So this is what we get, a matrix. Then we used Seaborn's heat map in order to visualize the correlation in a better way. The not equals to true is another argument. If you don't give it, this is how the correlation looks like. So it will be simply colors and nothing else. But we have given not equals to true, so it gives us the values as well. And you can see the same thing. Average and sixes, number of sixes have most correlation, whereas number of sixes and strike rate or selling price and average, these are not the highly correlating features. So to summarize this session, we discussed about two libraries which are used for visualization and descriptive they are basically used for visualization. One is a Matplotlib and another one is Seaborn. Then we discussed about the drawing the plots. We discussed about the bar plots, histogram distribution, or a density plot called displot, then box plots, interpreting them, comparing the distributions using the his plots and the disk plots. Then we talked about the scatter plots to compare two variables, pair plots to compare more than two variables. And in the end, we used the correlation that can exist within the variables and also generated the heat map like this. So this is it for this session. Next time we'll be starting module 3, which is on probability distribution and hypothesis testing. So this is it for this session. Thank you.
Thanks, Jaymeet. A good presentation on the data visualization and distribution. And we like to have this record ended today. And if there are any questions, we will try to follow up them through the email. At this time, we look forward to your coming back on Monday with the module 3, which you have put down probability distribution and hypothesis test. I know this will be very interesting, and people will follow that with eager to see that they revise their probability and hypothesis, which is the basis for all the models. Okay,
Yeah.
thank you very much. I think we'll end the call here, stopping the recording.